Did you know there are mountains hidden deep in the ocean, some even taller than Mount Everest? It sounds like something out of a science fiction movie, but it's absolutely true. For centuries, these colossal structures remain completely unknown, lurking in the darkness of the deep sea. But how did we finally find them? The story of their discovery is a testament to human curiosity and incredible technology. It all started with satellites, not by looking down from space into the water, but by measuring the ocean's surface with incredible precision. Scientists noticed tiny, almost imperceptible bumps and dips on the sea surface. These weren't random waves. They were consistent, measurable features. What could be causing them? The answer was gravity. These massive underwater mountains, called seamounts, are so dense that their gravitational pull is strong enough to attract water, creating a slight bulge on the ocean surface directly above them. By mapping these subtle hills on the water, scientists could essentially see the invisible mountains below. It was a revolutionary breakthrough that opened up a whole new world. When we finally sent down remotely operated vehicles, or ROVs, what we found was breathtaking. Imagine a mountain range, just like the Rockies or the Alps, but completely submerged. These aren't just small hills. We're talking about colossal peaks rising thousands of feet from the abyssal plain. Some seamounts stand alone, like isolated giants, while others form long chains stretching for hundreds of miles, creating vast underwater mountain ranges. The tallest known seamount, Mauna Kea in Hawaii, is technically the tallest mountain on Earth if you measure from its base on the ocean floor. From base to peak, it's over 33,500 feet, dwarfing Mount Everest's 29,032 feet above sea level. When you see the side-by-side comparisons, it really puts the scale of our planet into perspective. The world we see on land is just a fraction of the story. But these seamounts are more than just giant rocks. They are vibrant, thriving oases of life in the otherwise sparse deep sea. The steep, rocky slopes of the mountains create a perfect habitat for all sorts of creatures to attach to. Deep water corals, some of which are thousands of years old, form intricate, colorful forests on these slopes. These coral gardens are unlike anything you'd see in the tropics. They don't need sunlight and have adapted to the immense pressure and cold of the deep. Sponges of all shapes and sizes also cling to the rock, creating a complex, three-dimensional structure. This structure provides a critical foundation for an entire ecosystem. It's a refuge, a nursery, and a feeding ground. Schools of fish like orange roughy and alfonsino congregate around the peaks. Squids, octopuses, and countless species of crustaceans crawl and swim through the coral branches. Brittle stars and sea stars carpet the seafloor, while bizarre and beautiful creatures, perfectly adapted to this unique environment, call these mountains home. For many species, these seamounts are the only place they can survive. They are isolated islands of biodiversity, and each one can host species found nowhere else on Earth. It's like discovering a new continent, teeming with life we never knew existed. The influence of these underwater mountains extends far beyond their immediate vicinity. They play a crucial role in shaping the ocean itself. As deep ocean currents, which are like massive, slow-moving rivers, encounter these towering obstacles, they are forced to change direction. The water is pushed upwards from the dark, nutrient-rich depths towards the sunlit surface layers. This process is called upwelling. This upwelling acts like a natural fertilizer for the ocean. The nutrients it brings to the surface, like nitrates and phosphates, fuel explosive blooms of phytoplankton. Phytoplankton are the microscopic plants at the very base of the marine food web. These blooms create massive feeding hotspots, attracting everything from tiny zooplankton to fish, and all the way up to whales, dolphins, and seabirds. So a seamount hidden thousands of feet below the surface can be directly responsible for creating a rich fishing ground and a haven for marine megafauna on the surface miles away. They are the engines that drive biological productivity in the open ocean, but their impact doesn't stop there. By redirecting and mixing ocean currents, seamounts help distribute heat around the globe. The ocean is a massive reservoir of thermal energy, and currents are the conveyor belts that move this heat from the equator towards the poles. By disrupting these currents, seamounts help stir the water, mixing warmer surface waters with colder deep waters. This mixing has a profound effect on global climate and weather patterns. The temperature of the ocean surface influences everything from the formation of hurricanes to rainfall patterns on land thousands of miles away. It's an intricate and delicate dance where a mountain range no one can see can influence whether a farmer in the Midwest has a drought or a flood. It's a powerful reminder of how interconnected our planet's systems truly are. The discovery of seamounts has completely changed our understanding of the deep ocean. It's no longer seen as a barren, muddy plain, but as a dynamic and geologically complex world filled with life and wonder. And we've only just begun to explore them. It's estimated that there are over 100,000 seamounts taller than a kilometer in our oceans, and less than 1% of them have been visited or sampled by scientists. Each new expedition with an ROV or a submersible brings back images of new species and new geological formations. We are literally in the golden age of deep-sea discovery. These hidden worlds face threats from deep-sea mining and destructive fishing practices, which can wipe out ancient coral ecosystems in an instant. Protecting these unique and vital habitats is one of the great conservation challenges of our time. Understanding them is the first step. Every time we map a new seamount or identify a new species living on its slopes, we add another piece to the puzzle of our planet. The deep ocean is the last true frontier on Earth, and its hidden mountains hold secrets we are only just beginning to unlock. The next time you look at a map of the world, remember the vast, invisible mountain ranges beneath the waves, shaping our world in ways we're only now starting to comprehend. Thanks for joining us on this deep dive into the Earth's hidden mountains. If you found this as fascinating as we do, make sure to hit that subscribe button and turn on notifications so you won't miss our next exploration into the mysteries of the ocean. See you next time.